Hello, this is NAP2's Silica Safety Awareness Training Program. At the conclusion of this training program, you'll know what silica is, where it can be found, how to recognize and identify tasks that put you at risk, know the health effects to include signs and symptoms of exposure, know the types of engineering controls and safe work practices to include PPE. You'll know key elements of the new OSHA silica standard, and ultimately, you're going to know how to work safely in and around silica. It is estimated that there's over 2 million United States construction workers exposed to silica each and every year in the U.S. Okay, that's quite a bit. Okay, so you might be asking yourself, what exactly is silica? Well, there's three types of silica. There's crystallite, tridymite, and crystalline. We're going to emphasize on crystalline because that's where the hazards is most exist. Crystalline is a component of soils, sands, and granites, and many other minerals. Okay, uh, it's some clays may have it, and several types of rocks. Okay, uh, and the most common of the silica is the quartz, and that's what I like to do is focus on that photograph of beach sand, and notice the beach sand. Um, Between the two piles, the silica on the right is 100 times smaller than that of the beach sand, and that's where the concern is. It's the crystalline silica. It's very small, very small. Where are you going to find silica? You can find it, as we mentioned, it's a component of several things like rocks and stones, primarily granite, but it's in the sand. All right, and sand is a major component of mortar, which is also utilized in cement, concrete, plaster. Not your traditional plaster, but when I mention plaster here, we're thinking about a three-coat plaster system, where a lot of cases in the old days they used to apply plaster in three methods, called brown coats, and that will have a cement-based plaster, which will have silica. All your bricks and blocks, your tile, and refractory brick. Refractory brick, for those that don't know, is a fire brick. It's used as an insulating brick for like fireplaces and kilns. Joint compound, joint compound like drywall mud, some of it may contain silica. And so the issue is perhaps if you're sanding that joint compound. So let's take a look at some of the occupations um, that may pose as a risk of silica exposure. Since it's in bricks and block and some stone, of course, the number one on the top here, I mean, they're in alphabetical order, is brick masons and stone masons. They're pretty at high risk. A construction labor, crane and tower operator, anybody that's an operator of crushing or a grinding machine, such as a terrazzo machine, you'll see that later in the slideshow. Grinding and abrading and buffing and polishing operators, heavy equipment mechanic, a plumber and carpenter. I mean, they're trades, but they always have the potential of being exposed to silica because it all depends on their task that they're involved with. If they're involved with drilling through a block wall in order to run pipes through, that particular task of hammer drilling, it can put them at risk of silica exposure. A carpenter, same thing. He might be building a wall and anchoring that wall to the floor, and that particular operation may expose them to silica, possibly silica exposure. You also have a number of other trades. Operating engineer. How about a painter that sandblasts? A rock driller, sandblast. Electrician, cement mason, and of course, in some cases, plasterer. So, you know, if these materials are being used by these occupations, what type of task that poses them at risk? Well, that's what we're going to discuss in the next few minutes is the task. A lot of the tasks that causes a high risk activity would be that are listed here: grinding, saw cutting, jackhammering, tuck pointing operations, abrasive blasting, rock drilling, any crushing. How about dry sweeping, demolition work, knocking down buildings or sections of a wall, and using compressed air for cleaning. And that's a common problem, blowing, using compressed air for blowing dust around. The photograph here is a gentleman. Actually his name is Barry Caldwell out of local one Philadelphia. At the time he's grinding deteriorated mortar joints. Okay, he's taking an actual grinder and he's grinding out a deteriorated mortar joint within the brick, and it is a pretty dusty operation. This is considered tuck pointing. It's a process within a tuck pointing realm. Notice that he's got a full face respirator on. He's got a pair of overalls on, so he don't take the dust home with him. But unfortunately, if you take a look at the dust plume that he's got in and around him, that's a lot of dust. So even if he's protected, how about the workers nearby? Would they be protected from the dust exposure? Probably not. Okay. Now, depending on the tools as well as the tasks that a worker is engaged in, they'll obviously the percentage or the risk of being exposed elevates. The number one out of a number of operations is a tuck pointer. It's one of the highest persons engaged in an activity that puts them at exposure. 89%. That's quite a bit. You got surface grinders, somebody jackhammers, the use of jackhammers and chipping guns. Walk behind saws. You're going to see a lot of saws in the construction world. Cutting saws within the concrete, or blacktop even. That poses a risk. Dry sweeping, using a shovel, being a laborer on a job site, working at a mixing mixer, that poses additional risk. May not be as high as the tuck pointer, but there's still, nonetheless, it's still a major risk. Okay. All right. So take a look at this photograph here on the left. This gentleman's using a pneumatic chipping gun, and he's busting out some concrete. And in that task, notice the dust cloud that's in and around the worker's face. That's what we're dealing with. That small particles of respirable dust is the issue. Where's it going to go? It's actually going to his lungs. There's no cure for silicosis. But looking at this photograph, if you probably already thought of it, there's ways of preventing this 100%. What I mean is you can prevent that dust from landing in the air. Okay, we'll discuss that through this program. There's actually three types of silicosis. There's chronic, accelerated, and acute. It all depends on the dose and duration. How long of an exposure that you're dealing with? How many years? Okay, so take a look at chronic silicosis. It's 10 plus years of exposure, even at low levels of silica. And accelerated silicosis is 5 to 10 years after high levels of silica exposure. Acute silicosis happens anywhere from a few weeks to as short as 5 years after exposures to high levels of silica. How would you know if you've been exposed or what your status is? An X-ray would need to be taken, and that X-ray will have to be evaluated by a B reader. Somebody that's a B reader is a person that's specifically trained in reading occupational exposures from an X-ray. Okay. Some of the symptoms of the silicosis can include coughing, fatigue, shortness of breath, weakness, weight loss, a fever, cyanosis, loss of appetite, chest pain, and even night sweats. Okay. There may be no symptoms at first, or it could take several years for these symptoms to develop. It all depends on the situation. But once it starts, the damage is already done. Okay. Other crystalline silica causes heart disease. It can cause heart disease, vascular disease, tuberculosis, kidney disease, autoimmune disease. And so there's a number of these diseases that could happen. In addition, how about COPD, chronic obstructive pulmonary disease, which includes emphysema, asthma, chronic bronchitis. Um, so overall, silicosis is a serious lung disease, and and silica is considered a carcinogen. So that's something that's the reason why you have to be concerned. You have to protect yourself out in the field. What I'd like to do is introduce you to a short film um, from a member of the International Bricklayers. His name is Tommy Ward. And Tommy Ward, he lost his father due to full wall silicosis at the age of 7. Um, and his father was a sandblaster, working in the field for a number of years. And he, unfortunately, he died due to his exposure to silica at a very young age. So let's take a look at this.
And I feel it to be my duty to make this report available to the working people of the United States and to their employers. This report shows how silicosis occurs, where it occurs, and what the disease is. The report emphasizes that these control measures, if conscientiously adopted and applied, that silicosis can be prevented.
When I first seen Francis Perkins' video, I was just outraged that in 1938, 60 experts spent just a year to figure it out. And to really make it simple, turn the water on or turn the vac on. My dad was a sandblaster for several years in his late 20s. Shortly after that, he became short of breath. We didn't know what it was. He had a couple collapsed lungs. And then finally the diagnosis came, it was silicosis. It took about 5 years to kill him, and we got to watch. The toughest thing was watching him come home when he couldn't work no more, and literally fell on the ground and cried. He said, "I can't do it no more." So the impact is huge. Anyone that's ever lost anyone knows exactly what I'm talking about, whether it's cancer or a sudden fall. But watching a loved one suffer is a real human toll. They didn't know then, and most people don't know now about the hazards of working around silica, dry grinding and cutting and polishing material that produces silica dust. The modern workforce can work safer. The silica standard can save lives. It will save lives. And frankly, it's going to save a lot of money. If over 50,000 people are dying every year from diseases they contract at work, some of them silica, imagine the cost. It's time to get the word out and let them know about this.
Okay, so what you think? That's a pretty sad story for Tommy Ward. Okay, but again, an exposure to silica is 100% preventable just by, like in seeing the video, turning the water on or turning the vacuum cleaner, the local exhaust ventilation on, will eliminate any exposure. Okay, and it will certainly reduce it to a level that will hinder any health effects. Because of stories like Tommy Ward and others, OSHA has developed a new Silica Control Standard. Okay, this standard is broken down to several sections, as you can see here. It's got the scope, certain definitions, specified exposure control methods, personal exposure limit, exposure assessments, methods of compliance, respiratory protection policies, housekeeping, written exposure plan, medical surveillance, communications of silica hazards, record keeping, and some important dates for compliance. This has been launched in 2016, and all contractors must now comply, whether it's in general industry and or construction. So I'm going to go over some of the key elements of this standard, and starting off with it's called an action level. Action level is defined as, according to OSHA, if you're involved in a task that's greater than 25 micrograms per cubic meter over an 8-hour time-weighted average, that's called a trigger level. The maximum exposure limit under OSHA for silica is 50 micrograms per cubic meter of air. And that's what we have to deal with. If a contractor is in between above 25, they have to have a silica control plan to eliminate those dust. If they're over, they cannot have the employee reach greater than 25 micrograms per cubic meter of air in an 8-hour day. And we'll discuss how big is that in a moment. But take a look at this this worker here. He's grinding out deteriorated mortar joints. And notice he's got a loose-fitting respirator on. And it's really a loose-fitting pamper. Pamper is a powered air purifying respirator. And how do you know it's a powered air purifying respirator? On his belt is the battery pack and blower, and as well as the filtering system for that particular respirator. Also found in the picture is a little pump, and that pump is designed to aid in assessing the worker's exposure over the time-weighted average, and we'll get to that in a second. But so it's 50 micrograms per cubic meters of air over a time-weighted average of 8 hours. So all day long, a worker will have to be evaluated to see what the exposure limit is. But how big exactly is the 50 micrograms per cubic meter? Well, if you take a look at a sugar packet, and one sugar packet, I'm sure you've seen these all over, there's various types, but if you can just picture that being spread over a football field, that's 50 micrograms cubic meter of air. So it's not very much. It's not very much. Right? So it's very small. Okay. So, because of the new standard, and it's designed to protect the workers, all employers must develop and implement a silica control plan. Okay. The trigger is 25 micrograms per cubic meter. The maximum exposure limit is 50. But an employer must describe in the plan all the tasks that are involved in exposure. So if I was an employer and I got workers that are going to use a hammer drill and a chipping gun or some walk behind saws, I would have to describe each and every one of those tasks, and to include incorporating what am I going to include to prevent that silica exposure? What type of engineering controls? Engineering controls could be water. It could be, some sort of ventilation and or vacuum system. Okay. How about some safe work practices? What type of respirator that I may have to have my workers wear for each one of these tasks? Because it may differ. Why would it may differ? Well, if I was going to use a hammer drill, for example, for 1 or 2 holes, I may only need to use a disposable face mask versus a full face mask. So there's going to be a difference based on the severity or the task that you're involved with. The plan must also describe what type of housekeeping measures that you are going to incorporate in order to limit the exposure. Housekeeping methods or measures would be like sweeping. How are you going to do that to limit the exposure? And of course, procedures used to restrict access. So what does that mean is, what are you going to do to restrict access to that area of work from outside contractors? So are you going to put some signs up or some barricades? A sign that's mostly used is what you see here. Danger, respiratory crystalline silica may cause cancer, cause damage to your lungs. Wear respiratory protection in this area, and only authorized personnel is allowed in this area. So in the plan, contractor has to list how they're going to restrict access from workers that are not engaged with the task. Okay? Going back to housekeeping, dry sweeping, for the most part, is not allowed under the new standard. You would have to, if you're going to sweep up an activity, following the activity, it's ideally that you would use like sweeping compound. Perhaps you can use a vacuum, one of your vacuum systems to vacuum up the dust. But what you don't want to do is use compressed air, because what happens is when you use compressed air, you're just going to blow it back up in the air. Okay, and like I said, that small particle dust is what it's respirable dust is what we're concerned with. So sweeping compound and or vacuum systems or wet sweeping. Some cases you can use a different style broom and fog spray the dust as you sweep it up, okay, or mist it. In addition, all employers must designate a competent person who will, once the control plan is written up, the competent person's one of their duties would be to implement that exposure plan on the job site. Okay, a person can be considered as a competent person is if they could identify existing and predictable hazards. They have the authorization to take corrective action. Okay, so the competent person could be your foreman. It could be just your senior guy on the job, but they have multiple. They have a big responsibility to make sure that all the elements in that written exposure control plan are being implemented on the job site. So again, it's an individual capable of identifying existing and foreseeable respirable hazards, and they must have full authority to take corrective action. Okay? Some of the duties that a competent person must do is not only identify existing foreseeable hazards. And what do I mean by that when you look at that first bullet point? Well, if a person is doing an activity like grinding a mortar joint and it's a windy day, a foreseeable hazard would be that wind will blow that dust, maybe perhaps around the corner or down the length of an elevation or a wall, and exposing other workers. So you have to identify existing and unforeseeable hazards. Okay, you have to train employees. One of the duties a competent person must be able to train employees. What needs to be trained? Well, if there's new equipment on a job site, such as vacuum systems, an employee must be trained by the competent person of like how to change the filters, what's the limitations of the vacuum system. What the limitations is. Can it be used for 2 machines or 1 machine? Can you add hoses to it? All that kind of stuff. And the competent person, for him to do that training, they must have been trained themselves. Okay. And lastly, as a competent person trains the employees, they have to make frequent and regular inspections throughout the project, and at various times, making sure that all the employees are utilizing these control measures as dictated in the plan. Okay. In addition, the control plan, or the OSHA standard, has spelled out 18 tasks, and they're listed here. There's 18 of them. So stationary masonry saw, hand saw, drivable saws, floor grinders, driving milling machines, heavy equipment, handheld grinders for tuck pointing, handheld grinders for just general use. So looking at this, there's 18 tasks here, and depending on the task that you may be engaged with on the job will dictate like a protocol on how you're going to protect yourself. Okay, so let's take a look at a few of them. So the first one is stationary masonry saw. So we'll take a look here. And if you're using, well, in this case, it's going to be a portable saw. All right, here's an entry. It's a handheld powered saw. You can see a little picture there. Okay, gasoline powered. Most of these are all gasoline powered, or it could be electric. Okay, but if it's electric, there'll be a different chart for it. But this being electric, as you can see here, generally all the newer saws, like you see here, are they come equipped with an integrated water system. So there's basically a nozzle on the bottom that you hook up a garden hose to, and it maintains water on the blade as you're cutting a unit. Notice that this particular saw would be designed to be used with water, whereas an electric one may or may not be because of electrocution hazard. Okay, most electric ones may come with a vacuum system, okay? Some sort of suction device in order to limit the dust and fly. Okay, so looking at this, and the chart's not it's pretty easy to read, but basically it's a matter of what type of respiratory protection you're going to implement. It depends on the duration. Less than 4 hours or more than 4 hours. If you're using this particular, according to this chart, if you're using this saw and you're using it outdoors for less than 4 hours, okay, there's no protection that's needed because you have a water system attached to the tool. Okay, so if you look at it, less than 4 hours, it's got none. When used indoors, you're going to need an assigned protection factor of 10. And what that means is when you see APF, it means that you need a minimum of a half-face respirator, as you see in the photograph on the right-hand corner. Okay, it's a half face, so it's a assigned protection of 10. If you're not doing it, then the contractor can be cited under the OSHA rules because you're not given the minimum protection. Okay. So here's an example of the stationary saw. This is what I wanted to first go to, but it's equipped with, again, if you see all these stationary saws, whether they're brick or tile, they all have integrated water delivery systems. So basically, there's a tray there, and you fill the tray up with water, and inside that tray, below the water, you'll have a pump. And as soon as you turn the saw on, some saws require that you turn the pump on and the saw. Other cases, as soon as you turn the saw on, the pump automatically engages. So it all depends on the model. But importantly, you have to operate and maintain that tool in accordance to the manufacturer's instructions. So for example, this saw, because it's got an integrated water system, if you are, and it's stationary, that's a key word too, it's stationary. It's not portable like the previous slide. Whether you're greater or less than 4 hours, according to this, you do not need any respiratory protection. Okay? But the key rule here, though, is that you're maintaining that tool in accordance with the manufacturer's instructions. And in most cases, that will mean that you need at least a gallon of water per minute going on the blade. Okay? So if you can ensure that you're using a gallon of water per minute on the blade, then you don't need to wear respiratory protection. But in most cases, the takeaway is I would at least wear one because you never know what could happen on a job site. But according to Table 1, this is you're good as long as you're maintaining that. So if you turn the saw on and you see some dust escaping, there's a good chance that the water is not coming out as fast as it should be. Okay, so an evaluation needs, an evaluation of that task will need to be set. Okay. But again, so any type, any type of tool that's going to be done on a job, there has to be some type of personal protection equipment implemented or some type of engineering controls to limit the dust exposure. But silica from grinding, cutting, and drilling are really cause a high exposure to silica. Okay. A lot of these new machines that are going to be that you may come across out there do have these systems available. Okay. Some are interchangeable, whereas you can use, depending on the manufacturer, you can use a Milwaukee vacuum system with a with a Bosch tool or vice versa. But in some cases, some manufacturers will not allow you to have interchangeable material equipment. Because they want you to buy their whole system, like Hilti. Some models are very specific, and you'll have to check with the manufacturer. So if you're going to use a cup grinder like here, and the vacuum system's Hilti, you're probably going to use a Hilti cup grinder as well, okay? Because it's a system. So let's take a look at some of these situations here. Now I mentioned Table 1 lists 18 tasks, and some of these tasks are listed in Table 1. So in this case, they're grinding stones. And you got a picture of without engineering controls, and then the one on the right is engineering controls. Notice the difference. I mean, just by incorporating water, it really cuts down the amount of dust that's being created. And the standard, the key takeaway here, the standard is not only protecting that worker that's engaged in the task, it's protecting the other workers in the vicinity of that operation. So if you look at the photograph on the right, any supply trucks or stock help or other employees within the facility, office employees, they're not gonna get exposed to the silica because you're using water, and that's a very most common engineering control. And there's no reason not to have at least water or a vacuum system. So let's take another. Here's another picture of that stationary saw in operation. Notice the picture on the left. You got dust escaping because that worker did not wait for the water to pump up through and hit the blade. Notice the one on the right. It's the blade gets saturated, so is the unit of masonry, and there's no dust. Okay, and the worker's wearing a half-face respirator just for an extra precaution, which is good. It's a good practice, good safe practice to do. Okay, here's another picture, a floor grinder, hand little 4-inch grinder, and grinding without engineering controls. Notice the plume of dust. I mean, it's virtually blinding, and versus the gentleman on the right. Now, the gentleman on the right, notice he's using a vacuum system, and it's several feet behind him. One part of the training that a competent person must do is to ensure that all employees, are using these types of equipment as stated by the manufacturer. So notice the length of hose is pretty lengthy here. It's about a 15-foot hose. If the vacuum cleaner if that vacuum system comes with a 15-foot hose, that's great. You've got a lot of maneuver using that vacuum. But it does not necessarily mean that if you're short, you can add another section of hose, because if you do, you're field modifying what that vacuum system is designed to do. Some manufacturers allow it because they have a high capacity motor, but some do not. And if they do not, of course, what will happen is you're not going to be the safeguards for dust exposure is not going to will be hindered on complying with that. Some cases I've seen workers that may attach a Y to the same vacuum system and run and have two workers doing two operations that are sucking to that same vacuum, and you'll see the dust start to because the dust that's generated is overwhelming the capacity of that vacuum sucking that dust. So that's an issue. There are vacuum systems out there that are designed to be utilized for more than one operation, but you'll have to check with the manufacturer. And generally, those types have 3 motors in them, and they're a lot taller. But they're out there. They're quite expensive as well. But so you want to make sure that you got the right vacuum system for the task at hand, and you cannot, and just know that you cannot field modify because you're going to lose the capacity of the vacuum. Okay. The vacuum's efficiency. All right, so here's another picture of a jackhammer being utilized. And just to reiterate again, the Silica standard is not only to protect the worker that's involved in the task, but the other fellow workers that are on the site. So look at the picture at the left, how those other 2 workers that are standing there are exposed. The one on the right is a very good a very good picture of just using water spray. Notice there's like virtually no dust. Nothing. So it's a so water is one of the most common methods for engineering controls. Okay. Here's a photograph of using a vacuum system. So you have water, and now you have a vacuum system. Very same type, similar picture that you saw earlier with the tuck pointer. Grinding deteriorated mortar joints is one of the highest tasks as far as exposures. Looking at the picture, there's like no dust that's being escaped by that vacuum system. So it's a very good operation. Typically, when a worker is going to be utilizing these systems and they haven't tried these before, ideally you would have a mock-up wall built and have the workers test these machines out and these devices out on the mock-up wall before they actually go to the building. Okay. So to have a little, you have a few trial runs. There's another operation of drill holes. Okay, some are closer than others, but you can imagine if a worker is doing this all day long over an 8-hour workday, what their exposure would be using the picture on the left. Okay, quite a bit. So on a picture, on the right shows some engineering controls involved, vacuum system, and virtually no dust is being escaped for that operation. So it's a very very good system. Okay. Another operation, hot mode demolition. I mentioned one of the occupations machine operators are often exposed to silica, especially when they're doing site work or work of this nature, where they're demolishing a section of a building, that kind of thing. However, most of these operating engineers, are enclosed in a cab that may have a HEPA filtration system within the cab itself. But some of the older models may not be so good. Okay, but you can eliminate a lot of the dust again by incorporating one of the easiest things to do: water systems. So you might see some of these misting cannons or water cannons, or occasionally I've seen it where they tapped into a local fire hydrant and used fire hoses to spray the area down as they demoed the building. Okay, so again, currently there are 18 tasks that are outlined in the OSHA standard. And each one of those tasks will provide the employer a guideline of what safety provisions they should incorporate to lower and eliminate the exposure to workers. Okay, and that includes the respiratory protection, vacuum systems, and so forth. Okay, all right. If you're involved with a task that's not listed in the 18, okay, the employer must do a total assessment, and basically that involves in the use of like an industrial hygienist. And what happens is a worker will be evaluated over an 8-hour workday on a task. And here in this photograph is a worker on it's a suspended scaffold, and they have see the blue pump on the right hand side of this worker, and they're wearing this for an 8-hour workday. And this might go on for a couple days during the week, so they have a good feel of what the exposure would be for that task, based on the equipment and what they're involved with. So what it looks like in a closer shot. So here's another worker, same thing. Okay, some of these pictures were actually helped develop the table 1 listing the 18 tasks. So this gentleman is using a portable saw. It's hooked up to a vacuum system, and you have the pump on the right hand side, and the little cyclone is what they call it. It's attached to the worker's shoulder near his face, and that'll capture any dust particles. And based on an 8-hour workday, that little capsule is sent to a laboratory to determine what your silica exposure rate is. And based on that rate, will dictate what type of protections you should be implementing on the job site. Okay, so it's a very important process. But if you're doing one of the 18 tasks already listed in Table 1, all this information is already done for you. It's only when you're not doing a task that's listed that a contractor has to do, or an employer has to do an assessment for that task. Okay. But one key thing is that if your equipment was to change, like a new vacuum system, here's another vacuum. This is a Bosch system. It's a very good system, by the way. It's only for one. It's only for one tool at one time. So you cannot add another length of hose to it. You're going to lose its efficiency and that kind of thing, like we mentioned. But it's one tool, one vacuum. So a lot of training goes involved. When are you going to change the filters? How do you change it? Okay. What's the so all those things have to be covered in your training program. Okay. In addition, because we're dealing with silica dust and a lot of those operations require you to wear a respirator, contractor is required to continue making sure that anybody that's going to be given a respirator has to have a medical evaluation. Okay, that's pretty big. You have to make sure that the employees are fit tested so that they could wear, they are medically cleared to wear a respirator. Okay. Part of the training that an employee must have, not only on the vacuum systems and tools being in place, but if you're going to be wearing a respirator, we have to train you how to wear a respirator properly, how to inspect it, how to clean it, and of course how to store it. So that's part of the OSHA standard, respiratory standard, which is part of this standard. Okay? You can't be involved in these tasks without including a respiratory protection of some sort. And once you get into the respiratory standard, once you're issuing respiratory protection, you have to comply. An employer has to comply with the respiratory standard. So you saw in some of the photographs, there's several different types of respirators that are out there in the market: full face, half face, N95s, and PAPRs, powered air purifying respirator. So based on table one, like you saw on the table, will dictate what type of mask you got to use. Okay, and if you got to wear any one of these masks to do your job safely, you have to have a medical evaluation. Contractors required to do that, and this is done at no cost to you. Okay, done at no cost to you. Okay, if you were to wear a respirator working with your employer greater than 30 days in a calendar year, it is a requirement of a new standard to have medical surveillance being conducted. And what that means is they have to offer you the ability to go get a chest X-ray to evaluate, see if you've been exposed to silica, and a pulmonary function test, and of course a tuberculosis test. That has to be done. Again, this is no cost to you. It's anytime you're wearing that respirator more than 30 days in a calendar year. Okay. Another thing, just a little takeaway: if in the event that you're involved with some of these types of operations, one of the simplest ways to create a silica control plan for the employer is the website Work Safely with Silica. This is managed and developed by CPWR, and basically you can create a silica control plan within like 10 minutes by just clicking on that Create a Plan green box that you see in the photograph. Most contractors are using this because it's very simplified. It's OSHA compliant, and it guides through the process of making sure that you're in compliance with the new standard. Okay. So workers must look for labels. So what you should do on a job site is look for the labels. Look for the labels on the bill of materials to see if what it contains. If it contains silica, then you should have access to the safety data sheets for that material. Okay, because it brings up a flag if it contains silica, especially in some of the tasks like cutting and grinding and drilling. Those are really big and important. You must have training. Okay, got to have training on every operation that you're dealing with, new equipment on a job site. And so that you know how to better protect yourself. So in closing, we talked a lot through this training module, and I believe now you should know what silica is and where it can be found. You should be able to recognize and identify tasks that put you at risk. You know what the potential health effects of silica. How about the types of engineering controls? We spent a little time on that. And work safe practices to include personal protection equipment that can limit exposure. Okay. And the new OSHA standard. Okay. This now includes the Silica Awareness Training Module. Thank you.